shock absorber ZF Cdci. The ZF Cdci is a dual tube shock absorber, electronically adjustable through a solenoid located in the piston. The main components of these shock absorbers are the hollow rod, hollow because inside there is a cable connected to the car. Along the rod we find a rebound spring on the rebound stop. Then there is the solenoid and the piston. If we dismount it, we find the guide, of course, with an oil seal, the body, the cylinder, and the bottom valve. It works as any other dual tube shock absorber. So in compression, when I push the rod in, I create a pressure between the piston and the bottom valve and a vacuum between the guide and the piston. The pressure and the vacuum oblige the oil to cross the piston. Volume of oil equivalent to the volume of the rod crosses the bottom valve and goes into the chamber, while a volume equivalent to the cylinder less the rod crosses the piston and comes here. Then, in rebound, here there is a pressure. Between the piston and the bottom valve there is a vacuum, so the oil is forced to return back. Since the volume of oil crossing the piston is lower than the volume between the piston and the bottom valve, an amount of oil equivalent to the volume of the rod crosses the bottom valve and comes to the inner cylinder. Of course, the guide includes the oil seal on the top, a bushing, and a segment. This segment is very important because without this segment or with a washed segment, during the rebound, the oil can pass between the rod and the guide, comes here, and from these holes returns down. You don't see the holes because there is this rubber, okay? And a certain amount of oil has to pass in order to lubricate the oil seal. But if the segment is washed and too much oil crosses the guide, then happens that the oil do not cross the piston because cross the guide. And if all the oil cross the guide, between the piston and the bottom valve is created a bubble of air and then an oil gap in compression. So on this shock absorber, the main problem could be an oil gap in rebound because some dirty in the bottom valve, and in this case you have to make the remanufacturing of the bottom valve, as we will show later, or a compression, an oil gap in compression because the oil is passing through the guide instead of between the piston. In this case, you have to change the segment, or in this case, you can beat here little bit in order to press the segment versus the bushing and increasing the sealing between the rod and the guide. Now we will see step by step all the passages. Remember that now we can open the shock absorber with the Mangusta or on the lathe machine. Then we have to make the thread on the body, and you can make the thread on the lathe machine or with the steel tap by hand. Doesn't matter, it's your choice. Then you have to reduce also the length of the cylinder. And as soon everything is done, you can close it as any other standard dual tube shock absorber. The shock absorber can be opened on the Mangusta as well as on the lathe machine. The shock absorber can be thread manually as well as on the lathe machine. Make your choice. Dismount all the parts and clean them carefully. If any issue with the solenoid or the cable, keep ready the tools to dismount the Cdci piston of 36 or 40 mm. Only in this way you can replace them. Unscrew the lower part of the piston using the proper tool. Be careful because the wire will move too. So, as soon as possible, remove the vise and proceed by hand. Being careful, do not force the wire. When dismounting the piston, it is suggested to replace the O-rings. Look to the catalog, finding the proper ones. If needed, you can also replace the original cable with 52006. Then block the piston on the vise and tie it again. In case of oil gaps in Rebound, especially if because dirty into the bottom valve, it must be dismounted and remanufactured using the kit 21120. Let's see how. Block the bottom valve on the lathe machine or on the drilling machine and penetrate the chamfer with a center drill. Then put the tool into the vise and the bottom valve into the tool, and with a punch or a weasel remove the chamfer. Dismount the bottom valve and clean each component. Once the bottom valve has been dismounted and cleaned, replace the broken chamfer with the nut 21120A and the bolt 21120B. The kit 21120 is composed by a bolt and a nut that replaced the original chamfer. Fit the shims on the bolt. If needed, they can be replaced with new ones with inner diameter 5.10 mm and outer diameter 19 mm. Look on the catalog for the wall range. Also, the calibrator can be replaced with a new one with smaller bypass area. In some cases, the bypass area is created directly on the body of the bottom valve. Sand it with some paper to reduce its bypass area. Fix the nut on the bolt and screw it by hand. Double check that all the parts are fit properly and they can move up and down. Tie the nut and the bolt with the tool, but without forcing. Double check again if the shim can move up and down. When remanufacturing a twin-tube shock absorber, take always a look to the proto catalog, choosing the proper kits to replace the oil seal and reman the bottom valve. In the case of an Audi A8 D3 front equipped with a ZF Cdci, Emetec suggests to measure the inner diameter of the body and, if it is 43.0 millimeters, then choose the kit 50315. While if the inner diameter is more or less 43.5 millimeters, then choose the kit 50462. Open the bag, pulling out all the components. Be careful, do not damage the O-rings. Thread the body and reduce the length of the inner tube. Look to the tutorial related to twin tube shock absorbers for more details. Then fix the bottom valve on the inner cylinder, the body on the vise, fit the inner tube into the body, fill the oil. Remember that the inner tube must be full of oil, and with the rod in, the outer tube must be full within the 50 or 70% of its length. Then fit the piston and the rod in. Proceed checking if the bottom valve is clean and if its bypass is balanced with the piston one. To do it, push the rod in. If the oil rises along the inner cylinder, keeping it full or almost full, it means that the piston in compression is softer than the bottom valve, as it must be. If, on the other hand, the oil rises along the interspace and the internal cylinder tends to get empty, it means that the piston in compression is harder than the bottom valve in compression, which will generate gaps in rebound and therefore noise. Fit the rebound spring in and push it into the inner cylinder. It is suggested to replace the scraper segment into the guide, fit the guide in, pull the rod out in order to close the shock absorber with a lot of air inside. Once the guide has been fitted in, force the rod up and down looking for any oil gap. In many cases, inserting the guide, the small oil gaps disappear. Remember that the thread must be long enough to ensure that the thread ring will block the guide before reaching its end. In any case, the O-ring or the lip of an oil-sealed row 11 must work on a smooth area, otherwise will be damaged and the shock absorber will drop oil. So, after placing the O-ring, insert also the centering ring, so a ring with a special shape that ensures that the O-ring will keep the round and original shape. Fix always this ring as suggested into the proto catalog. Then screw the thread ring, at the beginning by hand. Don't force at the beginning, otherwise you can destroy the thread. Start screwing the thread ring with a short level and then tie it with a longer one, not vice versa. Control that the position of the thread ring is correct, and then insert the pressurizer. Double check that the diameter is the required one, lubricate its tip and force into the dust seal. Then pressurize more or less at 4-5 bars. Then remove the injector and clean the shock absorber.